Welcome to Math Class, where math is made simple and fun. Whether you're here to learn, revise, or boost your skills, you're in the right place. Let's dive into today's lesson, but first don't forget to subscribe for more videos. Today we are going to talk about hyperbola. Hyperbola is part of the conic section that we talked about in our previous videos. We talked about that of a circle, that of what? Parabola, ellipse, and now we're going to talk about that of hyperbola. Now, a hyperbola is a set of points in a plane such that the absolute value of the difference of the distance of each from two fixed points is a constant. Now, each fixed point that we are talking about, the fixed point, is called focus. So we have two separate fixed points. Then the point midway between the foci. So the foci is the plural form of the focus. It's called the center. So I will draw a diagram for you to visualize that one. Then the line containing the foci is called the transverse axis. It's called what? The transverse axis. The graph is made up of two parts called branches. Each branch intersects the transverse axis at a point called the vertex. Now, let me give you a diagram that represents what I'm talking about here. Alright, so we have this. This is this is how hyperbola is. Okay, so we are saying that the fixed point, each of them is called a focus. So we have one here, focus, and another one here, another focus. Now, we are saying that the point midway between the foci is called the center. So this place is called what? The center. It's called the center. The line joining the foci is the transverse axis. Now, this is the line which is joining what? The focus or the foci, which is the plural form. And it's called what? The transverse axis. Now, the point. Now, this is a graph, and this graph is made up of two parts called branches. Each branch intersects the transverse axis at a point called the vertex. Now, these are the two branches that we're talking about. It intersects the axis at a point. This is what? A vertex. There's also another vertex. Okay. So this is how it is. Now the point here, which is on this axis here, it is called what? The co-vertex. The co-vertex. We have another one here. Co-vertex. Alright, so that is how it is. So we have a focus here, vertex. Co-vertex is in the center. Alright. So basically that's how a hyperbola looks like. Now let's talk about the equation Equation of what? A hyperbola. Equation of a hyperbola. So equation of a hyperbola. Alright, so let me take my plane again. So I have this. I have this here. I have y and I have what? X. Now these are the branches. Alright. We have the branches here. Now we have the center here. Then we have a focus. Another focus here. We have 2. Let's name the coordinate negative c0. This one the x-axis, but these are the negative side. Let's name this is f1 c0. Now the vertex is here, another vertex is here. The distance from this point to this point is a, and from here to here is also a. It means that the whole of this will be what? 2a. Now this is the constant that from the definition of the hyperbola we are talking about. Now let's see, let's take a point on this here. Let's say point x, y. Now the distance from the second focus to the point P, minus the distance from this point P to the focus 1 is equal to this here, which is the 2a. So this is how it is going to be. So it means that f2p minus f1p is equal to 2a. Alright, so from the definition, we said that hyperbola is what? A set of points in a plane such that the absolute value of the distance of the difference of the distance from each point from to fixed point is constant. So this is going to be equal to what? This 2a and is constant. So let's see how it's going to be. So now we have our equation in the form. We have it. So our definition, we have f2p minus f1p being equal to what? 2a. Now from the diagram, our f2p will be equal to what? The root of, now let's look at it. This f2p, that will be x minus c. So you get x plus c, then y minus what? 0. So you get y squared there. So this is going to give us x plus c all squared plus y squared. Then with our f1p, that one too will give us x minus c all squared, then plus y squared. This is going to be y minus 0, so we still get y squared. That's why we have it there. So let's put it back to this and see how it is going to behave. Alright, so let's go straight to that. So this is going to be root of x plus c all squared plus y squared be minus the root of x minus c all squared plus y squared to be equal to 2a. Now let's take this one to the other side. So we have root of x plus c all squared plus y squared will be equal to 2a plus the root of x minus c all squared plus y squared. Now we want to get rid of the square root, so we square both sides. So we are going to square the whole of this, then we square the whole of this, and this is going to give us what? X plus c all squared plus y squared being equal to this will give us 4a squared plus 4a root of x minus c squared plus y squared. Then plus, so this is going to multiply by itself, so I still get x minus c squared plus y squared. Alright, so we have this. Now let's see what happens next. Okay, so with this, let's try to expand the ones here. So this is going to give us x squared plus 2cx plus c squared plus y squared being equal to 4e squared plus 4e root of x minus c squared plus y squared. Then plus, let's expand this to get x squared minus 2cx plus c squared plus y squared. Now looking at both sides of the equation, we have this going with this, then c with this gone, y with this gone. So now we have 2cx being equal to 4e squared plus 4e root of x minus c squared plus y squared. Then minus the 2cx. Now let's see what happens next. We can decide to bring this one to the other side. Now I have 2cx plus 2cx being equal to 4e squared plus 4e root of x minus c squared plus y squared. Now this is going to give us 4c squared x being equal to what? 4e squared plus 4e root of x minus c squared plus y squared. Now we can decide to divide through by what? 4, and this is going to give us what? Cx being equal to a squared plus a root of x minus c squared plus y squared. Now we still have, let's bring this one to the side. So we have cx minus a squared being equal to a root of x minus c squared plus y squared. Now we still have our square root in there, so we want to get rid of it. We will square both sides again. So I'm going to square this side and this side too. So what happens here? So we are going to get this side alone will give us c squared x squared minus 2cx a squared, then plus a exponent 4, a exponent what? 4, right? Then this side will give us a squared, then this will go, so we'll have x minus 2 squared plus y squared. what happens next? All right. Okay. So let's try to expand the one here. So you have c squared x squared minus 2acx. So a squared plus a exponent 4 being equal to a squared out. We are expanding this. So we have x squared minus 2 minus 2. Okay, so this is c minus 2cx plus c squared plus y squared. Now this is multiplying through. So we have a squared x squared minus 2a squared x cx plus a squared c squared plus a squared y squared. So let's add this side, c squared x squared minus 2a squared cx plus a exponent 4. Now this and this gone. So it's left with c squared x squared plus a exponent 4 being equal to what happens? Then we have a squared x squared plus a squared c squared plus a squared y squared. Alright, so let's continue and see what happens next. So we have c squared x squared. Can bring this side here. So we have minus a squared x squared. Let's add this one. So now we have minus a squared y squared being equal to, now this is left with only this. So we are left with a squared c squared. Then bringing this one to the other side, we have a exponent 4 here. Now we can factor x squared out here for the first two terms. So this is going to give us x squared c squared minus what? A squared minus a squared y squared being equal to, factor a squared out, c squared minus what? A squared. Now let c squared minus a squared be equal to b squared. So I'm going to replace this and this with what? B squared. So let's see what happens. So we are going to get x squared b squared minus a squared y squared being equal to a squared b squared. Now let's divide by a squared b squared throughout. A squared b squared, a squared b squared, a squared b squared. Now what happens? When we simplify this, we're going to get x squared on a squared minus y squared on what? B squared being equal to 1. In general, this is the equation of what? A hyperbola. When it is in this form, this is what? The equation of what? Hyperbola. You see, this is quite similar to that of the ellipse, but the negative sign here makes everything what? Different. So this is that of what? A hyperbola. That of what? A hyperbola. Okay, so that's the equation of what? A hyperbola. So now next video we're going to talk about some simple descriptions on this type or on this hyperbola. Thank you for watching. Welcome back to math class. Alright, so in this video we're going to talk about the equation of hyperbola when the transverse axis is on the x-axis. So hyperbola So when the transverse axis is on the x-axis. Now we said that the transverse axis is where you find the what the foci. So when it's on the x-axis, what happens? Okay, so let's take this diagram. Then we have a hyperbola like this. So when this one lies on what the x-axis with a focus, let's name this one C0, and this is going to be negative C0. The vertices which lies on this, in this case what, negative A0, then we have what, A0, this y-axis, this one x-axis. Okay, so when it's in this form, its equation is given by x squared on a squared minus y squared on b squared being equal to 1. Alright, so when it's in this form, this how the equation will be, and the center is at the origin. So you have center being what, 0, 0. Then you have the vertex. You see, in this case, the vertex lies here. We're going to get plus or minus what, A0. Then we have the co-vertices. So this the co-vertex will be, it lies on the y-axis. So going to be 0b, then we have 0 negative b. So the co-vertex will be 0 plus or minus b, because we have the positive side and the negative side on it. So plus or minus b. And what will be the foci? Now the foci, it lies on what? This axis, the x-axis. So I'm going to get what? The plus or minus C0 as our foci. Now in this case, when you have this, the C, to get the C squared, will be going to be A squared plus B squared. Now remember when we were doing that of the ellipse in our previous videos, that one was called A squared minus B squared, but in this case it's different from that. So it means that C will be equal to the root of A squared plus B squared. Alright, so that is that. So when the transverse axis is on the x-axis. Now the second part, so when it's on the y-axis, when the transverse axis is on the y-axis. Okay, so this is how it's going to look like when it's on the y-axis. So I'm going to get this on the y-axis like this. So what happens? We have our focus 2 being, so in this case, what will it be? It's on the y-axis. So I'm going to get 0, negative C. Then we have y1 being 0, C. Then the vertex will be this one, this. Our vertex will be 0, A. Then we have 0, negative A. Now the co-vertex becomes this one will be now B0, then we have negative b 0. Alright, so in this case, the equation, when it's in this form, the equation is given by y squared on a squared minus x squared on b squared equal to 1. Alright, so it means, so in this case our center is 0, 0. Now the vertex, now it lies on the y-axis. So we have AA, so it's going to be 0 plus or minus A, and the co-vertex will be half plus or minus B 0. So it's like it's on the x-axis, the co-vertex in this case is on the x-axis. And what will be our foci? It's on the y-axis, so there's 0 plus or minus what? C. So that is how it will be. Always our C will be equal to the root of a squared plus b squared. Alright, so that is that. That is that. So let's take an example. So some examples on this section. Alright, so the first example, find the vertices and locate the foci and the centricity for each of the following hyperbolas, and sketch the graphs of the equations. Now the first one is x squared on 16 minus y squared on 9 equal to 1. Then the second one is y squared on 9 minus x squared on 16 equal to 1. Alright, so let's dive into the question. So find the vertices and locate the foci and the eccentricity. The eccentricity here talks about it talks about how the conic section deviate from what? Being circle or being in a circular form. Alright, so when you have eccentricity being equal to 0, then you have a circle. And also if you have eccentricity being equal to 1, you have a parabola. When it's less than 1, you have an ellipse. And when it's greater than 1, you have hyperbola. Alright. So let's start with the first question. So solution, we have this x squared divided by 16 minus y squared divided by 9 being equal to 1. Alright, now you can compare this. This is in the form x squared on a squared minus y squared on b squared being equal to 1. So when it's like this, you see that the axis or the transverse axis is on what? The x axis. It's on the x axis. So let me go back. So we check that one. So when it's on the x axis, see the equation is in the form x like this. So means that the first equation is in this form. Alright, so let's see. So by comparing, our a squared will be equal to 16. So it means our a will be equal to 4. Then also our b squared will be equal to what? 9. So our b is equal to what? 3. And our c squared is equal to what? A squared plus b squared. So c is equal to root of 16 plus 9. Then get root of 25, which is what? 5. So we have our c to be what? 5. Okay. Now the vertex when it's on the x-axis, the vertex we have plus or minus a 0. So this is going to be plus or minus 4 0. So this is the same as 4 0 and negative 4 0. Then the co-vertex will be what? 0 plus or minus b. So the co-vertex of 4 on the y-axis. So we're going to get 0 plus or minus 3. It is the same as 0, 3 and 0, negative 3. Alright, so that is those are the vertices. Now let's look at that of the foci. Now it is on the x-axis, so it will be what? Plus minus c 0. Then we get our c being 5. Then we have 0. It's going to be what? 5 0 and negative 5 0. Okay, so that is that. Now the eccentricity, which is represented by this, is equal to c on what? A. And our c is 5 and our a is 4. So that's the eccentricity here. Alright, so we have to sketch it. So you have to sketch the graphs. So the first one for the graph. Now we know our vertices. Then we know our foci. So let's sketch our graph. So we have this. We said from the equation that this one it lies on what? The x-axis. So it means that it's going to fall here. So let's, even from the vertices, let's see how it is going to be. Now the vertex, we have 4 and negative 4 0 and negative 4 0. So if we have, say, 1 2 3 4, so you have 4 here, 1 2 3 4, another 4 here, and this are the negative side. We have the vertices here, and the foci was negative 5 and 5. So we have 5 here, and we have negative 5 here. So it means that it is going to be in this form. It is going to be in this form. And this is the focus, which is 5 0 and negative 5 0. Alright, so these are the vertices. The co-vertices. We have 3 and what? Also negative 3. Alright, so that is how it is going to be. That's our graph for the equation given, the hyperbola given for the eye. Now, let's move on to that of the ii. We have ii, which is y squared on 9 minus x squared on what? 16 being equal to 1. We are going to compare this one. This one is in the form y squared on a squared minus s squared on what? b squared equal to 1. And this, when it happens, it means that the hyperbola or the transverse axis is on what? The y-axis. It's on the y-axis. So by comparison, our a squared is what? 9. Then it means that our a is what? 3. And also our b squared is what? 16. So our b is what? 4. Then our c will be equal to the root of the a squared plus b squared, which is 16 plus what? 9. Then get root of what? 25, which is going to give us 5. So with this, we know all this. So the vertex, now it is on the y-axis. The vertex will be what? 0 plus or minus a. And this is going to give us what? 0 plus or minus 3. So our point will be 0, 3, and also 0, negative 3. Alright, the covertex is this one. In this case, it falls on the x-axis. We're going to get plus or minus b 0. We're going to get plus or minus 4 0, which is 4 0, and negative 4 0. Alright, and what to be our foci? What to be our foci? So let's see. Since it falls on the y-axis, our foci will be 0 plus or minus c, and this is going to give us 0 plus or minus 5. It is 0, 5, and also 0, negative 5. Okay, that is how it is going to be. Now, since we have this, we can easily sketch our graph. So let's see how is it going to be. Y-axis, x-axis. Okay, 0. Now, the foci is 0 and negative 5. So 0, negative 5, and 0, 5. So we have, let's say, our 5 is saying negative 5. This will be our focus. And another focus. So what would be the vertices? The vertices were 0, 3, and what? Negative 0. So we have 3, 3. So our 3 falls here, 3 falls here. So these are the vertices. So this is going to open like this. Going to open like this. So to pass through this, these are the vertices. Now the co-vertices, we have 4, 4, so negative 4, and what? 4. So it is simple as that. Now you have to sketch it. Alright, so that is that, the question. So we are asked to find the eccentricity. So it's the same thing, the C on A. Then we have our C being 5. And in this case, our A is 3. So this is how it is going to be. Thank you for watching. Welcome to Math Tutorials, where math is made simple and fun. Whether you're here to learn, revise, or boost your skills, you're in the right place. Let's dive into today's lesson. Today we are going to talk about finding the equation of a tangent and normal to a hyperbola. So, equation of tangent and normal to a hyperbola. So just like we did for other ones in our previous videos, where you have to find the equation of hyperbola. We can use the implicit differentiation to um, do that one. Alright, so if the equation is given, then we have to find the equation of the tangent and normal to that particular hyperbola given. So for example, find the equation of tangent and normal to the hyperbola x squared on a squared minus y squared on b squared is equal to 1 at the point A sec theta, then B tan theta. Alright, so in this case, given a question like this, now we can easily solve this by means of implicit differentiation. So let's see how it goes. So with this, we have the equation given, equation of that hyperbola given, minus y squared on b squared being equal to 1. Now we can use implicit differentiation. Now the result that we get will be the gradient of the tangent. So when we differentiate here, it will be the gradient of the tangent, and the negative reciprocal of that gradient gives you the gradient of the normal. Alright, so let's move on with this. So when we get the gradient of the tangent, it is easy to obtain that of what? The normal. Yes, because the normal is perpendicular to what? That of the tangent. So in this case, when it happens, we know that perpendicular lines, the product of their gradient is equal to -1. Yes, that's why the gradient of one is the negative reciprocal of the other. Yes, that's why it is like that. Okay, so in this case, we have the equation here. We can go by the implicit differentiation. So we differentiate this. So when we differentiate this, we are going to get this is a constant. Alright, so we have 2x divided by a squared minus we have 2y divided by a squared dy dx. So when you differentiate with this, whenever you see a y, you add the y dx. Then when you differentiate the constant, you're going to get what? 0. Now we want to make the y dx the subject. Let's leave this one, 2x divided by a squared being equal to 2y divided by b squared dy dx. Now we want to get this, so we can divide by this. So when we divide, our dy dx will be equal to 2x divided by a squared divided by 2y on what? B squared. And this will be what? 2x divided by a squared times b squared divided by what? 2y. And this is gone. What is left here? Our dy dx will be equal to b squared x divided by a squared y. But we know that from the point given, points given here. We have A sec x, so this is x sec theta, and then sec b tan theta, and y. So we can substitute the one there. So this is going to give us b multiplying the x is what? A sec theta divided by, so this is b squared. Then we have a squared multiplying b tan theta. Now we have bb. So basically this is going to be b sec theta divided by and a tan theta. Alright, so this is how it's going to be. Now, still on it, this can be written as b on a multiplying sec theta, which is the same as 1 on cos theta divided by tan, we have tan theta, which is the same as sine theta on what? Cos theta. Alright, so this can be like this. Alright, so it is dividing. So in this case, what happens next? We have b on a multiplying 1 on cos theta times cos theta on what? Sine theta. And this will, now we have b on a multiplying 1 on sine theta. So the dy dx will be equal to b on a sine theta. Now this is, so the gradient of the tangent is b on a sine theta. Alright, so we have this as the gradient of what? The tangent, and with a point, so at a sec theta and what? B tan theta, we can find our equation of the tangent. Equation of what? The tangent. So we have y minus y1 equal to m, x minus what? x1. Okay. Now this is the point, and we have the gradient here. So you have y minus b tan theta being equal to, the gradient is b on a sine theta. Then we have x minus this is x1, so a sec theta. Alright, so still on it. Okay, so to get rid of the fraction, we can multiply it by a sine theta, and this is going to give us ay sine theta minus ab sine theta tan theta being equal to b multiplying x minus a sec theta. Now let's expand this side. So we have a y sine theta minus ab sine theta tan theta being equal to bx minus ab sec theta. Alright, so this AB and AB, let's group them. So now we have AY sine theta minus BX then equal to AB sine theta tan theta minus AB sec theta. Alright, so let's continue. That AY sine theta minus BX being equal to AB out. We have sine theta tan theta minus sec theta. Okay, now at this side, only this one. We know that this here, this one, AB, this is the same as sine theta multiplying sine theta on what? Cos theta minus 1 on cos theta. So we have AY sine theta minus BX. Alright, so let's continue. So you have AY sine theta minus BX being equal to, now we have AB is going to be sine squared theta divided by cos theta minus 1 on cos theta, and it's going to be the AB, then I have sine squared theta minus 1 divided by cos theta, AY sine theta minus BX. Alright, so in here, this one, we can do something. You know that sine squared theta plus cos squared theta is equal to 1. Now, we want to get rid of all of this and replace it with cos. So, meaning that our cos squared theta will be equal to what? 1 minus sine squared theta. But we have sine squared theta minus this. Now we can manipulate this. We can write it in the form AB. We can write it in the form, so let me write this. AY sine theta minus BX being equal to negative AB. Now, this becomes, we have 1 minus sine squared theta all divided by cos theta. Now, it means that when I multiply this by this, I'm going to get out my negative. I'm going to get the negative 1 AB. Then this is going to be positive. Alright, so it will go back to the positive sine squared theta that we have. Now, we know that our 1 minus sine squared theta is cos squared theta. So we can easily write that one there. So 1 sine theta minus BX negative AB. Now we have cos squared theta divided by cos theta. Then AY sine theta minus BX will be equal to negative AB multiplying cos theta. So 1 is gone. So this can be written as AY sine theta minus BX plus AB cos theta being equal to 0. And this one becomes the equation of what? The tangent. The equation of the tangent. The equation of the tangent. Now, with the gradient of the tangent, you can easily find that of what? The gradient of what? The normal. Now, we have the gradient of the tangent being B on A sine theta. So gradient of the normal will be equal to negative a sine theta divided by b, and that one becomes what? The gradient of what? The normal. The gradient of what? The normal. All right. So with this, together with the point a sec theta and b tan theta, we find the equation of the normal. So we have y minus y1 being equal to m x minus x1. So putting in this, substituting the now y1, we have b tan theta equal to our m, which is negative a sine theta divided by b. Then I have x minus a sec theta. Alright, so this is going to be, now we want to get rid of the fraction, so we're going to get by minus b squared tan theta being equal to negative a sine theta and x minus a sec theta. So this is how it's going to be. Okay, so let's try and expand this one here. So we have by minus a b squared tan theta being equal to negative a x sine theta plus a squared sine theta sec theta. Alright, so for up to that point, that's how it's going to be. So okay, so that's how it's going to be at that point. Okay, so let's see, we still have our by, then with this x thing, let's bring it to this side, the plus ax sine theta, then I have a squared sine theta sec theta plus b squared tan theta. So this can be written as ax sine theta plus by, and this will be equal to, okay, we have this one here, which is going to be, this is the same as 1 on cos. So we have a squared sine theta divided by what? Cos theta. Then plus b squared multiplying the sine theta divided by what? Cos theta. Now sine theta, cos theta, sine theta, cos theta is common. So we can write that one as ax sine theta plus by being equal to sine theta on cos theta multiplying a squared plus b squared. But this is the same as tan. Sine theta on cos theta is the same as tan. We have ax sine theta plus by being equal to a squared plus b squared tan theta. Now we can write this one as ax sine theta plus by minus a squared plus b squared tan theta being equal to 0. So that is that. So the question was demanding for the equation of the tangent and the normal, and that this is the equation of the normal, and that's we have the equation of the tangent here. So that is that when you're given the equation of the hyperbola, you can do implicit differentiation to get the gradient of the tangent, and after that the negative reciprocal of that will give the gradient of the normal together with the point. Then you solve for your equations for each of them. All right. So thank you for watching.